usually you will have two questions from section A, and section A you cannot select the question, you have to answer all of the questions. And this time the coordinator planned to prepare the question for session A from chapter 6 and 5. So you must study chapter 6 and 5 for your final exam. And today I'm going to do a little revision for chapter 5. Last time I have a problem with my throat and I was not able to deliver chapter 5 using online, but I provided you the video for chapter 5. But today I would like to explain it online so that maybe you can understand more compared to your personal study. Okay, yourself study with yourself. So in the Google Classroom, I already uploaded the file for today's lessons with title Ulangkaji 22 June. Okay, 22 June. Okay, and from the slide, I will explain to you the way on how can you utilize the Excel file so that you can do the calculation correctly and you can prepare for your final exam. And also, I would like to stress here how you should write down your answer in your answering sheets during the final exam. So I will start for the presentation. Okay, can you see my screen now?
Yes, Doctor.
Okay, this is my screen. Okay, the title for this today is Ulangkaji chapter 5, which is division chapter 5. And in the slide, I think we already have kind of all of the solving method or all of the example on how to solve the questions which could come out from chapter 5, which is the linear regressions. Okay? No, chapter 5 is body. Yeah, you can have a linear regression, and then you also might ask to do some hypothesis. Okay, so this is an example. If you are given data here and you are asked to do analysis, so sorry, you will provided two data. One is the first one, and you will have the second one. Okay. Normally, the first come will serve as the x-axis, and the second one will be the y-axis. So, if you're given the data like this, and in the question they ask you to plot data, okay, and then you have to do it like this, lah. Okay. But in this chapter, it's about a linear regressions. So linear regression, we have to do the linear regression using the least mean square method. Okay. In your chapter 5, you have the linear regression, and the method is least square method. Okay, it's called as least square method. So this one is only to have the y equal, maybe in mathematics they call it as c plus mx. Okay, but in our statistic, you will have the equation like this: y is equal to b beta 0 plus beta 1 x. Okay, this is the equation that you need to derive from this data. So then the question might be asking you to predict some value. Okay, the first one is you asked to create an equation. The first one. The second is to predict, and then the hypothesis that we can do in this chapter is to evaluate. When we plot a graph, we have sort like this. So you are going to have the slope here. Okay, yx, where the slope in mathematics m is equal to delta y divided by x. So you are going to test the slope. But in this statistic, it's called as beta 1. Okay, and then you are going to do the hypothesis on this value here. So in mathematics, they call it as C. Okay, but in the statistics subject here in this chapter, we call it as beta 0. So we are going to evaluate this by using the null hypothesis, then alternate hypothesis. Okay, we have the beta 1 H0 and also the H1. H0 and also the H1. And then when you draw a line, you are going to discuss about the relation between the x and y. Okay, what is the relation? The relation here, we can evaluate it using two methods. One is coefficient of determination, the other one is correlation coefficients. So now let's see the next page. So this is the page where I already calculated the value of the data from the this data from this given raw data here. So in your Excel, you can prepare x, y, x square, y square, x times y. Okay, and then from here you are going to have the accumulations. This is the accumulation of x, accumulation of y, accumulation of x square, accumulation of y square, and then finally you have the accumulation of x times y. So this is all of the data you have to provide. From here, you need to arrange all of this value again. So in your examinations, when you start to answer this question here, first of all, you have to write down the value of x as coefficient value of x, y, x square, y square. equal to, what is it? Okay, in this case, we already have the answer here. If you don't write this, you will have less marks because I cannot see the way you solve the problem. So you have to show in your answering paper. So from there, you have to calculate the SXY, okay, which is the SXY equal accumulation of X times accumulation of Y divided by N, okay, and then you have the SXX, and then you can calculate the beta 1, which is equal to SXY divided by SXX, and have beta 0 equal beta 1 times accumulation of X divided by N. So this formula you can find it in your notes. So actually I calculated using the Excel, and I can find it. I can have the value of, as shown in this figure here, in this screen. Sorry, hang on. So then you can, if you are using the Excel, so this is the view that I already prepared for the Excel. I advise you to do or to make a file like this. For example, one, this is the data that I got, and this is data 4612, and now I have 4612. I calculated using the formula, and we have the formula here, and also from the calculations you can have the value of beta 0, beta 1, which is the beta 1 is equal to C24 divided by C27. Okay, C24, which is the SXY divided by SXX. So you have 0.274. Okay, you are going to have the 0.2724, and beta 0 you have the 0.489. So this is the answer for calculation SXY until beta 0. Then in your answer, when you're answering this question here, finally you have to write down, okay, the equation which is y is equal to, from this answer here, you can see here, you have to write down the answer which is the finally y is equal to 0.49. You can write like this, plus 0.27 x, and then the question here you have to predict when the x is 38, for example. So for that you have to write down if x is assumed to be 38, y equals 0.49 plus 0.27 times 38 equal to how much? So in this answer here we got it 10.84. You have to write down 10.84. So this is for the deriving the equation for the least square lines, and also to predict what are the value of y when the x is 38. Okay, because we don't have 38 here. Okay, 37, 11. The value is 11. Okay, when x is 37, the y is 11. But when the x is 38, y equal to. So this is the function of the equation here. Okay, and then you might ask to test the hypothesis of slope. Then you have to calculate the hypothesis of slope. This is the method how we calculate the hypothesis of slope. You have to write it in detail like this. Okay, first, this is the first step. Define the hypothesis. What is H0? What is H1? Like this. You have to write it like this. In this case, it's beta 1 equal to 1. Beta 1 is larger than 1. In some cases, they might ask this to 2. Okay? But in this question, the number is 1. There's also a possibility where you ask beta 1 equal to 3. For example, beta 1 is beta larger than 3. Or maybe you ask hypothesis null alternate hypothesis beta 1 not equal to 3. Okay, it can come in any ways for this symbol here. So from this one you have to define whether it is 1 tail, 2 tail. Okay, whether it's 1 tail or whether it is a 2 tail test. So in this case it is 1 tail test, and the population standard deviation is unknown. The n is less than 30. So in this case, we are using the t-test. And from the table, we have it 1.812. So the t is the what we call it? We call it as the degree of freedom. Okay. Degree of freedom is 10, which is 12 minus 2, and then you have the comma. No. T-test, we have what comes first is the value of alpha. Okay. T, alpha, U. Okay. T, 10, 0.05, 10. Okay. And then in this case, when you look at the table, we have the table for the histogram statistic. Not histogram, the statistic table. Look at the t distribution, whereby t distribution must be in table number 7. Okay, you look at table number 7. Yeah, this one 0.05, 10. So this is the value 0.05. View is 10. So 1.812. Okay, you will have the value there 1.812. So this is the value 1.812. So 1.812 here is used to judge the hypothesis. Okay, 1.12. reject HO if t-test is larger than 1, which is the t-table. Okay. Reject HO if t-test is larger than t-table. Now the t-test, we have to calculate it. We already have the t-table, which is 1.812. So to calculate the t-test, we got to know the value of MSE. Before we can calculate the MSE, we have to calculate the SSE. Okay. And before you have to calculate the SSE, you have the SYY. And the SXY here is, you can get it from the first step here. Okay. And then from here, you can calculate it as the formula provided in your slides. And then you can calculate it. This is the value, the test calculation. The BC here, beta C, is referred to this value. Okay, this is the beta C. If the exam or the question is like this, H0 beta 1 equal 3, H1 beta 1 larger than 3, so that means the beta C is 3 here. Okay, this beta C here is 3. So in this case, you use it as 1, and when you calculate it, you have 9 minus 19.8512. So now the t-test, we got it minus 19.8512. So it is actually smaller. So it is not the same as the condition where we can reject the HO. That means we cannot reject the HO. We can conclude that the slope is equal to 1. Okay, it is fair to reject the HO because of not enough evidence. The conclusion, we can conclude that the slope is equal to 1. Okay, we cannot reject the HO. This is for the slope hypothesis. And then you might also ask to calculate or to do hypothesis on the intercept. Okay. Precaution here. You have to bear in mind that the t-test, you have two different equations, which is for the slope and also for the intercept. Okay, the intercept is the formula. Okay, beta 0 minus beta C divided by square root of SE times 1 divided by n minus x divided by n, and divide by SXX, if I'm not mistaken. So you can see the for the intersection. So Sorry, this is very complicated here because I do it calculation in Excel, so the notes become Excel formula. Actually, the formula for this one is can calculate as t test equal to this is for beta 1 divided by MSE divided by uh, SXX. Look, look. This is for the slope. And then you have the intercept. For the intercept, you have a little bit long equation. This is for the slope. For intercept, you have another equation which is quite long. Beta 0 minus beta c divided by square root mse times 1 divided by n plus x bar, which is the mean uh, square of the mean divided by s x x. Okay, so this we have two here. Okay, for the slope and for the intercept. So for the intercept, make sure you are using the correct equation. Don't do mistake whereby you want to do hypothesis on the intercept, but you are using the equation for the slope. Okay, make sure when you want to do hypothesis on the intercept, you use the t-test formula for the intercept. So from this equation here, when we calculate it, we have the t-test 0.32318. And in the Excel also I have it like this. Okay, this is for the slope, and then I also got it for the hypothesis for the intercept, and this is the value here minus 32318, whereby the t table is 1812. Now the t test, if it is larger than the t table, okay, reject the HO. But then actual the t test is smaller than the t table. So the conclusion here is decision is not to reject the HO. So this is the conclusion whereby the t test here minus 3 0.32318, and the t table is 1.812, and it is smaller, so it's contradict. Okay, so the decision here is do not reject. Okay, do not reject. And then you have the conclusion. In this chapter, in this hypothesis, first, this is very important, you have to write it down. Secondly, the equation. The judgment method, and then you have to do the division, and then you have to do the conclusion. You have all of these, you have full marks. You don't have either one of these, you cannot have the full marks. Okay, we have the hypothesis, judgment standard, and then you have the calculation with the equations, make the decision, and then you make conclusion. Then you can have the full marks. And next is for the coefficient determination and coefficient correlation coefficients. So these two, usually we use it to make conclusion on the reliability of the data or to justify the relation between those x and y data. So don't do mistake. R square for this one is R. It is not the same R. Okay, it is not the same R. For example, you already calculate R2 for the coefficient determination, and then you are asked to calculate the correlation coefficient. Don't square root the R2. It's wrong. Okay? Write down again your formula. Write down again your formula like this. Okay? So in the Excels, I already do it like this. Okay, by the way, when we want to set square root, you can square root it. Okay, is equal to SQRT, this value here. Okay, we have the same value here, but please calculate it again using the formula provided. Okay, even though you are going to have the same value, so make sure that you can calculate it with this formula. Okay, because I'm calculating it using the Excel, so the value of the range of value here and the value here is not. I don't have the error in calculation, but if you calculate this R square, R square, you might say that it's equal to 0.85. And people ask you what about the R? So maybe you can square root 0.85. So you got 219. Okay, 9219. In this case, you are going to got, you have it 9219. So this is a, what we call it, small decimal point, whereby we want to transfer it to percentage. You got it 92%. This one you will have the 94.7 or maybe 85. Okay, 84.7 or 85. It is a percentage. Sometimes calculation, miscalculation, you can have it 93 or 91 in some cases. So please recalculate it using this formula. Actually, this one you can derive to this formula here. Okay, but in your examination questions, I would like to ask you to recalculate it using this formula. For other lectures, they might say that it's okay. R2 is equal to square root of R. No, R is equal to square root of R square. It's okay like that. But in calculations, in your final exam, make sure that you have the equations before all of the answer. So these are all of the example, and in this slide here, I already provide you the answer for example 2, whereby this is another questions. You have data in X, also in Y, 1.2, 50.6, and so on. You have 10, the N is 10, and then you have to predict what happened when the X is 500, and then you have the next hypothesis here, and you calculate as I shown in the first example. So please do it. You must have the answer just like in the slide. Make sure you can have the answer just like in the slides. And then there are also example 4. In this case, you can see here, hypothesis is not necessarily using value of 1. Okay, beta C could be 1, 2, 3, and so on. In this case, they use 5 for the hypothesis. So make sure you can do this one, example 5, and also you can have example 4. So in today you have more time here. You have extra time today for your self-study. I would like you to do the example 5. Okay, example 5, and I will submit it before the next class. Submit example 5 with the answer. So in slides, in the Excel file, I already done on the example 2 with the answers here, and I think you can prepare the same things, understand how to calculate and understand how to rearrange in a faster way, because you can use the Excels, you can calculate it using your calculator. Normally when we have the face-to-face exam, you have to calculate using your calculators, and you have to show the table like this so that we can sure understand that you calculated your